We're a technology company involved in waste to energy. We scoured the world looking for technologies that are cheap. The waste to energy products that are in Europe is extremely expensive. We were looking for small units which released very, very little emissions. We're involved with containerized factory wastewater treatment plants, and unbeknown to me, the project lead for that particular project at a multinational company is sitting just there. We're involved in hazardous and general industrial waste to steam and electricity on site. We have developed a 40-foot containerized plant that can take waste coal ultrafines, the waste coal that's creating all the acid mine drainage, untreated waste oil, and we're testing sewage sludge now and turning that to electricity. And something very near and dear to me is activated carbon production, where we're producing a syn fuel, which we can take to a biodiesel. As was mentioned, we won the Global Clean Tech Innovation Program for South Africa, where we went to San Francisco and met many of the other country winners. It was a very worthwhile and rewarding program, and I wish the new lot, I think in a room just over there, had a good time with that as well. We bought the technology and we actually have the patents for that, and everything we're doing now is manufactured in South Africa. So it's a counterflow vortex combustion chamber. Very, very high-speed air creates the vortex with huge energy output. We can put contaminated flue gases through there, syngas, which combusts. We can also put in waste oil, untreated waste oil, to heat, and waste coal ultrafines, and as I said, we're testing sewage sludge at the moment. So the way we approach a company is that we conduct a bankable feasibility study. So we determine what the wastes are, the quantities, the calorific values, the moisture, and we tap into the GIST database for that. We look at the waste handling, how that waste is delivered to our systems. Do they need dewatering? Do they need baling? Or is it continuous feed? And we look at the ash removal as well. We then pair that waste to our technology. Then we bring in a specialist engineering company who harvests that heat and takes that heat to either a heat exchanger, boilers to steam, steam turbines to electricity, or organic Rankine cycle to electricity, which we're very keen on. We look at site preparation through another specialist company, possibly the same as the heat harvesting company, for the steam piping and electricity distribution on site. And then we look at the financial modeling. We look at capital costs, whether they want to outright purchase it. We can also finance the plants where we charge the client a cost to destroy the waste and either a rand per ton of steam or a rand per kilowatt hour of electricity. So the first plant we did, just to prove that we destroyed all the worst kind of emissions, was a medical waste plant that was put into Cape Town. It's effectively pyrolysis in the main chamber up there, and that's the afterburner up the top there, which cleans the gases, takes it to heat. This particular client wanted hot water. The market in South Africa is large. I'm not too sure I want to remain in that market, but it's a 300 million rand per annum market. The current average cost of destruction is 7 rand or 7.5 rand per kilogram. We can do it for 2.5 rand per kilogram, which is a huge saving for the company. We also manufactured a smaller unit. It's a 20-foot containerized unit where we can take hazardous waste, and we've proposed it for 2 mines in Rustenburg for their PMR facility. This is the industrial carbonaceous waste to steam, which we're very excited about. And there was some talk earlier on from the Department of Environmental Affairs, how they're trying to fast-track various licensing issues through. On Thursday, last Thursday, after 6 months, I received a letter from Mark Gordon, who said that basically our first site is the MPACT facility at Springs, where they have paper pulp and plastic waste. If we take that waste on site, put it through our waste-to-energy facility that has to remain on site, and we create steam and deliver that steam back to their process, there is no need for a waste management license, and there's no need for an EIA. So all our projects from now on can open, because effectively they were parked. So this particular project, they have 6 coal boilers, and from the steam that we're going to be producing, we can knock out 2 of their coal boilers from their waste. Their current waste they're producing is about 33,500 tons per annum that we will divert from landfill. Other possible sites in Enstra and Gauteng, there's Sappi and there is Kimberley-Clark. Together, there's 55,000 tons per annum of waste, and they're waiting to see what happens with the MPAC plant. Klip River at Nampak, 25,000 tons per annum of waste that we can divert, and Roslyn in Gauteng, again Nampak, is 45,000 tons per annum of waste. So waste is truly a resource. We always say recycle first, but the waste that cannot be recycled, we like to thermally treat. This is another site that the project lead for my waste-to-energy project, or the wastewater project sitting over there, will be very familiar with. It's actually Cadbury's in Port Elizabeth, where they have 8 tons of chocolate waste per day and confectionery waste, which we can actually take to heat to 2 of their current boilers that are currently there. The same company, which is actually now called Mondelez, it's no longer Kraft Foods. In Nigeria, they produce cocoa powder. They have 50 tons of spent grain per day that they're taking to landfill. Landfill diversion would be about 18,200 tons per annum. Just to go back, you'll see that the actual capital cost of these plants, they're not large. And the reason being is that the afterburner is a relatively small piece of kit. Current incinerators with the new air emissions legislation means that they have to have a huge amount of ceramic filters, chemical dosing, activated carbon dosing, which makes the actual plants extremely expensive and very, very large. So they don't really have at the factories, there's no room to put them. So this is another factory in Gauteng. It's actually the Unilever factory, where they produce margarine from sunflower oil. So they actually produce the sunflower oil there. They have silos of sunflower seed husks, which we can also use, as well as their oil distillates and acid oils to produce steam on site. I've done a site survey at Indosa at the River Horse Valley, Peter Maritzburg, Maiden Wharf, and Phoenix, which are all Unilever sites, and they have an idea where they'd like to actually have a central facility where all the non-recyclable waste can go, where there would be an anchor tenant, where they would produce electricity, and they would invite other companies to bring their non-recyclable waste too, and they would give that energy to the municipality. This is the containerized system that I was talking about earlier. We've done a bankable feasibility study for a mine in Middelburg in Mpumalanga. They have a tremendous amount of the waste coal ultrafines. Now, this is the stuff that just combusts, causing methane and all nasties to go into the air. It also creates the acid mine drainage problem. What we've found is this particular site in Middelburg, they have installed rented diesel generators because Eskom can't provide them the power. It's costing them 3.6 Rand per kilowatt hour. We can actually put in from 60 tons of waste coal ultrafines per day, we can create 2 megawatt hours of electricity. And that's from one container with 2 afterburners in it. We're looking at other sites in Witbank and Carolina who also uses diesel generators. This is an interesting scenario. It's slightly different from the last one. There's a brickworks in Mpumalanga in Middelburg and a coal mine right opposite. They're taking the coal ultrafines across the road to the brickworks to manufacture the bricks. What they want now is the coal to go across there to create 5 megawatts of electricity, 3 of which will be sold to the local municipality. This is a cobalt mine in DRC, which has 1 million liters of waste oil sitting on site, and we'll be creating 4 megawatts of electricity out of that. I'll quickly rush through. And finally, the activated carbon plant. South Africa imports $20 million worth of coconut-based activated carbon, or coconut shell-based activated carbon for their coal, for the gold industry. We've developed a 40-foot container, again containerized, where we can create 1 ton of activated carbon from 4 tons of coconut shells. But it goes further. We want to look at macadamia nut shells in Nelspruit. We want to look at all the invasive plants that can be chipped as part of the rural development, where we create activated carbon, which is a market which has doubled from 1.8 million 2 years ago to $1.8 billion 2 years ago. It's a very, very nice industry. And finally, this is the wastewater treatment plants that we built, one in Elandsfontein, which is now Premier Foods, one containerized unit in Swaziland where the payback was, I believe, 2 years, Davi. And we sold 2 40-foot containerized plants to the Kraft or Mondelez chewing gum factory in Burj Al Arab in Egypt. So we believe very much in these containerized units. And all I can say is waste truly is a resource. It's not a waste. Anything with calorific value we can use. Thank you.